Hello viewers, in today's session we are going to discuss another important problem from functional equations, and in this session we are going to take up this problem in which we are given a function f from R to R. R is the set of real numbers such that this function f it satisfies this functional equation, that is f of alpha plus x is equal to f of alpha minus x plus 4 alpha x for all values of alpha and x belonging to the set of real numbers. Then we have to find out the form of the function f of x. So now let us see how we can solve this functional equation and we can get the value of f of x, right? So this functional equation can also be written as f of alpha plus x minus f of alpha minus x is equal to 4 times alpha x. So taking this term to the left hand side. So let us call this equation as equation number 1. And remember here alpha and x belongs to the set of real numbers. Now here let us replace this alpha by x. So let us see the changes in equation 1 when we replace alpha by x. So we have x plus x, then here we have f of x minus x, and here we have 4 x and x. So replacing alpha by x, so we get this equation f of 2x, and here we have f of 0, and here we have 4x square, right? So let us call this equation as equation number 2. Now what we will do, will differentiate equation 1 with respect to x. Now derivative serves as a powerful tool to solve functional equations. So let us differentiate both sides of equation 1 with respect to x. So we can write d by dx of f of alpha plus x, and then we have d by dx of alpha f of alpha minus x, and here we have d by dx of 4 alpha x. Now here we'll treat x as a variable and alpha as a constant. So we have here f prime of alpha plus x, and by chain rule the derivative of alpha plus x is 0 plus 1, and here we have f prime of alpha minus x, and by chain rule the derivative of alpha minus x is 0 minus 1, because the derivative of x is 1, and here also the derivative of x is 1. The derivative of alpha is 0, and here also the derivative of alpha is 0. So here we have 4 alpha being a constant, we can take it outside the derivative operator, and here we have d by dx of x. So we have 4 alpha times 1. The derivative of x with respect to x is 1. So here we have 4 alpha, right? So now we can rewrite this equation as f prime of alpha plus x, and here this negative sign when multiplied with this negative sign it becomes positive. So we have f prime of alpha minus x, and here we have 4 alpha. Now let us call this equation as equation number 3. So now let us replace alpha by x in equation number 3. So we'll get f prime of x plus x, and here we have f prime of x minus x, and here we have 4x. So this is f prime of 2x, and here we have f prime of 0, and this is equal to 4x. And let us call this equation as equation number 4. So now let us replace x by 0 in equation number 4. So we'll get f prime of 2 times 0, and here we have f prime of 0, and here we have 4 times 0, right? So what we have done, we have replaced x by 0 in equation number 4. So here we have f prime of 0, here also we have f prime of 0, and 4 times 4 multiplied with 0 is 0. So this is 2 times f prime of 0, that is equal to 0. So dividing both sides by 2, we have f prime of 0 is equal to 0. So this result shows that the derivative of f of x at x is equal to 0 is equal to 0. So now substituting this value of f prime of 0 is equal to 0 over here, that is in equation number 4. So we'll get f prime of 2x plus 0 is equal to 4x. So we can now write f prime of 2x is equal to 4x. So this is an important equation in order to find out the form of the function f of x. So now if we closely look at this equation, and if we take 2x is equal to say z, then this equation takes the form f prime of z is equal to 2 times z, right? Because 4x can be written as 2 times 2x, and we are taking 2x is equal to z. So now we have this equation f prime of z is equal to 2z. So f prime of z is equal to 2z can also be expressed as f prime of x is equal to 2x, right? Because here we are now changing the variable z to x. So we are changing z by x. Now we can also arrive at this equation if we start with replacing 2x by x, right? So if we replace 2x by x in this equation, then we'll get f prime of x, and here we have 4x. 4x can be written as 2 times 2x. Now we are changing 2x to x. So we can now write x for 2x. So here we have 2x. So we'll get the same equation. So this is a differential equation, and we have to solve this differential equation by integrating both sides with respect to x. So we can write f prime of x as d by dx of f of x, that is equal to 2x. Now integrating both sides with respect to x, we have here 2x dx, and c is the constant of integration. So the integral of d by dx of f of x is simply f of x, and here we have 2, and integral of x is x square over 2, and here c is the constant of integration. So we have f of x is equal to, here 2 and 2 get cancelled, so we have x square plus c. So now we see that the form of the function f of x is a quadratic function, and f of x can be given by x square plus c, where c is some constant, right? So viewers, the solution of this functional equation is given by this function, that is f of x is equal to x square plus c, and this function, it satisfies this functional equation. Now let us verify that this function satisfies this functional equation. Now here we have f of alpha plus x. So f of alpha plus x can be obtained by replacing x by alpha plus x. So we'll get alpha plus x square, and c is the constant, right? And f of alpha minus x can be obtained by replacing x by alpha minus x in this expression. So we have alpha minus x square plus c, right? And here we have 4 alpha x. So let us subtract both these equations. So we have f of alpha plus x minus f of alpha minus x. So we'll get alpha plus x square minus alpha minus x square, and here c and c get cancelled, right? So we are subtracting these two equations. So here we can apply the identity for a plus b square, and here a minus b whole squared. So here we have a square plus b square plus 2ab, and here we have a square plus b square minus 2ab. So now we can write alpha square plus x square plus 2 alpha x minus alpha square minus x square, and here we get the positive sign. So we have 2 alpha x. So these terms get cancelled, and we have 2 alpha x plus 2 alpha x, that is 4 alpha x. And this is how we can see that we have got the right hand side, right? So f of alpha plus x minus f of alpha minus x is equal to 4 times alpha x. So viewers, here it is interesting to note that this function f of x is an even function, right? F of x is an even function, and this can be proved by replacing x by minus x in this function, right? So we have f of minus x is equal to a minus x square plus c, and the square of minus x is positive. So we have x square plus c, and x square plus c is f of x, right? So f of minus x is equal to f of x, which suggests that the function f of x is an even function. But here the concept of even function can also be proved by using this equation number 1. Now let us replace this alpha by 0 in this equation number 1. So let us see what we get when we replace alpha by 0 in equation number 1. So we have f of 0 plus x, and here we have f of 0 minus x, and here we have 4 times 0 times x, right? So we are taking alpha is equal to 0. So we have here f of x, and here we have f of minus x, and here this term reduces to 0. So now taking this term to the right hand side, we have f of minus x. So this shows that the function f of x is an even function. The second important thing about this solution is that if we find the first derivative, then we have f prime of x is equal to 2x. The derivative of this constant is 0, and the second derivative is equal to 2, right? And after this, all the derivatives are equal to 0. So the important thing about this function, that is the solution of this functional equation, is that the higher order derivatives, that is the third derivative, the fourth derivative, and so on, the successive derivatives are all equal to 0.